All right, gentlemen. So we're definitely getting to the part of quadratic functions that require a lot of thought. But hopefully I'm going to set it up for you in a way that by the end of today's lesson, just by looking at the graph, you're going to know a lot of features. You're going to know whether it's going to be a wide graph, a narrow graph, whether it's pointing up or down, okay? And I'm going to show you how to find the vertex form of any quadratic equation. So it should be pretty easy. Now, when we're talking about analyzing a quadratic function, we got to first think about what the parent function is. Bless you. So the quadratic parent function is y equals x squared. Plain and simple. That is the parent function. That is the function that derives all other quadratic functions. Every other quadratic function on Earth is a manipulation, if you will, of the parent function y equals x squared. Now, hopefully you guys can remember that for y equals x squared, what's my vertex here? What's my axis of symmetry? How about that? My axis of symmetry is 0, right? So what's my vertex? Very good. Now, what's my y-intercept? 0. So what do we do when the vertex and the y-intercept are the same value? Plug in any value for x. Very good. What value of x would you like to choose for this one?
1.
Okay, everyone said 1. I think that's great. When x is 1, 1 squared is 1. So, yeah, 1, 1. And then it's the mirror image, okay? Since this is my axis of symmetry, I'm 1 to the right, so you go 1 to the left. So that would be my parabola, roughly. Does that make sense? Okay, that should be like common knowledge by now. Okay, now that's the parent function. Now we can shift that parent function by using what's called the vertex form of the quadratic function. And the vertex form is a manipulation of the parent function y equals x squared. And it is a manipulation in the sense of, bless you, in the sense of y equals a times, parentheses, x minus h squared plus k. We're going to analyze every single part of that equation in the next few slides. But when we're talking about vertex form, we're talking about y equals a times x minus h squared plus k. Okay? Now, let's talk about these different variables, a, h, and k in particular. If a is greater than 0, in other words, a positive number, okay, then the parabola is going to point downwards. Wrong. My bad. Sorry about that, guys. Yeah, we're all humans, but that's kind of cheesy. Sorry. So we're talking about upward. Okay. Sorry about that. Yeah, I had switched these around, apparently. No big deal. Okay. So if a is greater than 0, then the parabola points upward. So it does not matter where the vertex is. We know that it's just going to point upward. The vertex can be down there. It could be here. Or it could be here. All I know is that my graph will be pointing upwards if the a is greater than 0. So if a is positive, we're pointing up. If a is less than 0, if a is less than 0, then that means the parabola is going to point downwards. Does not matter where the vertex is. We just know that the end behavior of this quadratic function is pointing downwards. So be there. You can have the vertex there. Any which vertex doesn't matter. What matters here is the fact that A is less than 0, A is negative, so the graph will point downwards. Does that make sense? Okay. Now, if the absolute value of A is greater than 1, okay, this signifies a vertical stretch. Okay, sorry about that. So the absolute value of A, if that is greater than 1, then what happens is that the graph is going to stretch out. It's going to get thinner and thinner. Yes, you have a question, sir? No, we're doing this. Absolute value is greater than 1. Okay, so the absolute value of A is greater than 1. I'm going to have a vertical stretch. That means that it's going to get narrower. So if I have y equals x squared, which here's my 1, 1, and here's my 1, and then I have 2, 4, negative 2, 4. Okay, this is my y equals x squared. If I have y equals 2x squared, let's show you how this works. When x is 0, of course, that's 0. But when x is 1 here, what's my y? 2. So 1, 2, negative 1, 2. When x is 2 here, what's my y? 8. So 2, 8, and then mirror image. Do you see what I mean by narrower? Now, if that was y equals negative 2x squared, it would still be just as narrow, but it would be pointing downwards. Thank you very much. As far as how wide the graph goes, we're talking about the absolute value. Now, when the absolute value of A is less than 1, in other words, it's a fraction, it's going to be a vertical compression. So that means it's going to get wider and wider. Again, my y equals x squared. That's y equals x squared. Now, if I have y equals 1/2 x squared, my y-intercept, of course, and my vertex is going to be 0, 0. What's the y value when x equals 1? 1/2. So 1/2 is here, and we're going to have 1/2 there. What happens when x is 2? 2, 2. Look at this. Is that not wider? Do you see the difference here, gentlemen? Yes? Okay. Fantastic. Now, let's continue. The h. The h is, if the h is positive, okay, the graph is going to shift to the left that many spaces. Because if you remember, the formula is x minus h. So if I have y equals whatever, x minus 5, or plus 5 rather, squared, that's a positive, but that came from a negative h. So that means I got to go to the left. So you always do the opposite. Correct, sir. So if the h is positive, you go to the left. If the h is negative, you go to the right. But let's focus on when h is positive. My y equals x squared. Okay, by now you should know this perfectly. That's my y equals x squared. If I say y equals x plus 3 squared, all I'm doing, literally, is taking every single one of the parent function points and I'm moving it left 3 places. So I go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and that is my graph. It is the same width, same everything, except shifted to the left 3 places. Does that make sense, gentlemen? Same exact procedure happens or occurs when h is negative, except when h is negative, you move to the right that many spaces. So again, y equals x squared. Oh. Okay, that's y equals x squared. And now this time I have y equals x minus 3 squared. So I have a negative h here. I have a negative value there. So I'm going to go to the right 3 places. So I go 1, 2, 3 to the right. 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 And there you go. Shifted to the right. Does that make sense? Very easy. Thank you, son. All right. Last thing, and then we could actually get to work here. If the k is positive, the graph shifts up that many places. That's it. There's no reversing here. There's no, oh, do the opposite. No, it's just straight up. So once again, y equals x squared. So that's y equals x squared. But now if I say graph y equals x squared plus 2, if before we move the points left to right, how are we going to move the points here now? We're going to move every single point, in this case, up because it's positive, my brother. So you go 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. Same exact graph, just shifted up. Literally. And last but not least, if k is negative, that means you're going down. So if I have y equals x squared, if anything, you should at least know the graph of y equals x squared by the end of today's lesson. Okay, so now I have y equals x squared minus 2. So I'm going to drop every point down 2. So I go down 1, 2, 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 and there it is. Same exact width, same everything, size, the shape, the width. The only differences are the point values because it was shifted up or down. Does that make sense? Okay, now, I'm going to show you how to graph this Morrow's way, not the book way. I don't like the way the book does it, so I'm going to show you my own way, and hopefully you'll see why it's a lot easier to do it my way, in my opinion. Okay, number 1. First of all, I want you to graph y equals x squared plus 2 squared plus 1. Now, on what I just talked to you guys about the whole h and the whole k thing, okay? What is the h here? Okay, very good. It says x plus 2, so that the h is really negative 2. So I'm going to be shifting my parent graph to the left, correct? What is my k here? Positive 1. So not only am I going to shift all the points from my parent graph left 2, but I'm also going to shift them up 1. So one method would be to graph the parent, okay, and you have the parent graph, and then move all of the points, and then graph a second graph. That's acceptable. It's doable. It will give you the right answer. It's going to be a little bit messy, but it is doable. Now, my way, I think, is a little bit better. Number 1, find and graph the vertex. Well, guess what, guys? That's the whole point of Vertex Form. They already give you the vertex. The vertex is the HK. So what's the HK here, gentlemen? Negative 2, 1. Very good. So negative 2, 1 is right there. That's my vertex, right? So that means what's my axis of symmetry? Negative 2, right? So I'm going to do this here just to guide myself. All right? Does that make sense so far, gents? All right, cool. Number 2, find and graph the Y-intercept. What is the y-intercept here, gentlemen?
5.
Yes, when x is 0, 2 squared is 4, 4 plus 1 is 5. Excellent, son. So 0, 5. 1, 2, 3, 4, 5. That's 2 to the right of the axis of symmetry. Go 2 to the left of the axis of symmetry. You are done. That's it. Done. Over. Now, you might see there's a 3 here. Why the 3? Why the 3, Moral? Well, if the vertex and y-intercept are the same ordered pair, what do? We plug in any value for x and find the corresponding y value. Then graph the ordered pair you found along with its mirror image. So, in my opinion, that's the way to graph it. Graph the vertex, graph the y-intercept, mirror image, you're done. If the vertex is the same as the y-intercept, choose any value for x, graph it, find its mirror image, graph it, connect the dots, you're done. That makes sense, guys?
Yes, sir.
We're good?
Yeah.
Yes, sir? Okay, no worries. Thank you.
If the vertex
Yes, sir.
is the y-intercept, wouldn't it be the...
If the vertex is the y-intercept, then you have to choose values for x
Yeah, but
and find the y.
the parent function except with maybe an a value besides 1?
No, not, no, because the vertex could be 0, 1. So it could be y equals x squared plus 1. You're going to have there, the vertex is going to be 0, 1, and
Yeah.
so is the y-intercept. So no. Yes, sir.
When you have a value of a bigger than 1, you have to keep it along with it.
When the value of a
Bigger than 1.
is bigger than 1. No. You just do the same exact procedure, son. Same exact procedure, I promise. Find the vertex, find the y-intercept. If the vertex and the y-intercept are the same point, plug in a value for x and find the y. Okay? Thank you, son. Now let's do the monster here. Let's write y equals x squared plus 8x minus 5 in vertex form. Okay? I did a lot of research on this weekend, and I found a way that I really like. So I'm going to teach you that way. I think it's going to make a whole bunch of sense. You ready? First of all, this is the procedure if and only if I have a y equals x squared plus bx plus c. There is no a term larger than 1. Okay, the coefficient of x squared here is 1. You with me? Okay. So, number 1. Separate the c from x squared plus bx. Don't send it to the other side. Just separate it. So, for example, separating means that. I encapsulated the x squared plus 8x with a parenthesis, and I left myself a little space there because I know that's where the b over 2 is going to go. And then outside of the parentheses, I put my negative 5. So does that make sense? Separate c from the x squared plus bx. Does that make sense, everybody?
Yeah, that's right.
Okay. Step 2. Complete the square. So you know that when we complete the square, we've been trained to add b over 2 squared to both sides, correct?
Yes, sir.
But we're going to be writing this in vertex form. So instead of sending it to one side, then bringing it back to the other side, I realized that what that did is just waste time and confuse people. This is a much better way. You're going to complete the square, and you're going to subtract the b over 2 squared from the c instead of sending it to the other side of the equation. So, let me explain. B over 2 here squared is 4 squared, correct? So I completed the square by putting my 4 squared here. And now look what I did. I subtracted my 4 squared from my c value, which was negative 5. Does everyone see that? I completed the square, which meant that I have to add 4 squared, right? Normally I would add 4 squared over here on this side, right? But we're not doing that. We're reversing it, and we're subtracting the b over 2 squared from the c value, which is negative 5 here. Yes, no, maybe, kind of, sort of? Talk to me, people. Now, it's easy. Simplify and write in vertex form. Okay? X squared plus 8x plus 4 squared, that we just created a perfect square, x plus 4 squared. And negative 5 minus 16 is negative 21. You're done. Vertex form. So what's the vertex here? Negative 4, negative 21. Very good. What's the axis of symmetry here? Negative 4. What's the y-intercept here? 0, negative 5. Very good. Is this graph pointing up or down? Very good. Nice. Make sense? No, it's not narrow or wide. It's actually the same width as the regular parent function x squared. If it was narrow, this would have been 2 or 3 or 8. Okay, remember, when the a is larger than 1, I become more narrow, sir. Yes, sir. 0, negative 5 is the y-intercept, because when x is 0, don't you get 4 squared minus 21, which is 16 minus 21, which is negative 5. So my y-intercept will be 0, negative 5. Yes, sir. You do this procedure when the coefficient of x squared is 1. Now, what happens when you have a coefficient of x squared that is larger than 1? Well, in this case, we are writing y equals ax squared plus bx plus c in vertex form this time. Very simple as well. In fact, almost identical. Step 1. Separate the c from ax squared plus bx, just like the last time. Now, though, you're going to factor, whoa, my bad. You're going to factor, whoa, you're going to factor out a from the ax squared plus bx. Okay? You're going to factor out the a from the ax squared plus bx. And you're going to subtract it from c. So let me explain that again. You're going to separate the c from the ax squared plus bx. And in this ax squared plus bx term, you're going to factor out the a. And whatever a you factored out, you're going to subtract it from c. So, what is this man talking about? Let me show you. You pulled out the c. You separated the c. Right? You with me, guys? You separated the ax squared and bx, and you factored out negative 3, correct? And then you subtracted the negative 3 from that c. Does everyone see what I just did there? So the only difference here is the a that you factored out, you subtract it from the c value. Does that make sense? Okay. Now, complete the square and multiply b over 2 squared to the factored out a. So, when I complete the square here, b over 2 squared is negative 1 squared, correct? Notice how I'm going to multiply the b over 2 squared to the a that I factored out. Yes? Yes? No? Maybe? Kind of? Sort of? Okay? Now, simplify and write in vertex form. Well, there's going to be negative 3, x minus 1, because this is a perfect square. It turns into x minus 1 squared. And then negative 1 plus 3 times 1. So negative 1 plus 3 is 2. And I'm done. Yes, sir. I'm sorry, son? You can always factor something out. You just may be left with a fraction for b, but you always are going to factor out whatever's in front of the x squared, no matter what. Even if it doesn't come out pretty, you still got to factor it out, gentlemen. Does that make sense? Okay? Yes, I'm ahead of you already. For example, let's say I want you to write the following in vertex form, gentlemen. Okay, one last example here. Let's say I tell you, write y equals 4x squared minus 12x minus 11 in vertex form. All right, let's go step by step. First, let's separate the c and factor out the a from the ax squared plus bx. So y equals, I'm going to factor out a 4. I'm going to be left with x squared minus 3x. I'm going to leave a space, and then minus the 11 minus the 4. I factored out this 4, and I have to subtract that from the c. Now, step 2, we'll do it in blue. Complete the square. So this is y equals 4 times x squared minus 3x plus b over 2 squared, which is negative 3 halves squared minus 11 minus 4 times negative 3 over 2 squared, because you multiply the b over 2 squared to the a that was factored out. And now it's easy. Y equals 4 times x minus 3 halves squared. I just completed the square. And then over here, this mess here, this is negative 11, and that's negative 4 times 9/4, so that's minus 9, so that would be minus 20, and that is your vertex form. Does that make sense, gentlemen? Yes? Awesome.